Suppose that we have a triangle and we know SAS about this triangle, which is to say we know the length of one side, the length of another side, and the measure of the angle formed where those two sides meet, the included angle. So in this case we have AC currently equal to 4.6, AB equal to 6.51, and angle CAB equal to 40.66 degrees. Now we can move C just along this horizontal line here. Same with B. We can change these. So the first thing we're going to do is we're going to create inside this triangle a right triangle by drawing a perpendicular line from C to AB. That segment that we create is the height of both this right triangle as well as the height of the original triangle ABC. Side AC is now the hypotenuse of this triangle right here. So since we have created a right triangle, we can use SOHCAHTOA. In this case, what we're interested in is the height, and what we already know is the hypotenuse, which we said was 5.73. So when we're talking about height, or opposite side, and hypotenuse, we're talking about the sine of the angle. So we have that the sine of 31.59 degrees is equal to 0.52, and we also know that the sine of 31.59 degrees is equal to the ratio of the height over the hypotenuse. So what we can say is that since the sine of angle A is equal to the height over the hypotenuse, that the height is equal to the sine of angle A times the hypotenuse. In other words, we multiply both sides times the hypotenuse. What we can do then is go to the area formula for the triangle, which is base times height over 2. So red base times green height over 2. We can replace height with what we calculated up here, which is sine of angle A times hypotenuse. So now we have base times hypotenuse times sine of angle A. Now we change the order up here a little bit, but it doesn't really change anything. So we have the base, and then we have hypotenuse times the sine of angle A, which we said is equivalent to the height. So this gives us the area of this triangle. Now let's look at the actual calculation. We have that the area of triangle ABC is equal to 6.93, which is the length of this red base, times 5.73, which is the length of this blue hypotenuse, or side AC, multiplied by the angle of the sine of angle 31.59 degrees, which is 0.52. When we multiply those together and divide by 2, we get 10.4. Now, as you can see, interesting thing is that as we change C, not surprisingly, because the height's not changing, the area is not changing. The base is also not changing. So when the height and base stay the same, the area will stay the same, even though both the hypotenuse and the angle measure are changing, but the way they're changing offset each other, so the area of the triangle remains constant. What we have done here is we've taken a procedure and we have consolidated it to create a formula. And that is to say that whenever we have SAS for a triangle, whatever the kind of triangle it is, we can use the formula of one side times the other side times the sine of the included angle divided by 2 to calculate the area of that triangle. It doesn't matter whether our included angle is greater than 90 degrees, we're still going to get an accurate calculation for the area of triangle ABC.